Let's look at an example together on this hypothesis testing process. So, a campus legend tells the story of two friends who lied to their professor by blaming a flat tire for their having missed an exam. The professor sent them to separate rooms to take a makeup exam, and on the first question, which was only worth 5 points, it was easy, but the second question, worth 95, asked them to state which tire. So, you're hoping that your accomplice here states the same tire. Now, suppose a professor at MCC wanted to study the likelihood that MCC students randomly choose the same tire or randomly chose the same tire. So he asked his students, if you were caught in a situation where you had to suddenly choose a hypothetically flat tire, which of the four would you say went flat? Left front, right rear, left rear. And then of the 58 students surveyed, 29 chose right front tire. So does this provide evidence that the MCC students pick right front tire more than the others? That's what we want to investigate. So in order to do that, the steps tell us that we've got to first identify the parameter that we're looking at and then verify the normal distribution. What's the parameter that we want to investigate? Well, we want to determine what's the likelihood of choosing a right front tire. If there's 4 tires to choose from, the long run probability of choosing right front tire is a 1 in 4 chance, or 0.25. So our parameter is p equals 0.25. Now, verify our normal distribution. We've seen this before. We want to take our sample size, multiply it times p, and then 1 minus p, and you find out that that ends up being greater than or equal to 10. So, what about our statement about the population? Remember, we are assuming something about the population and then work to show whether or not it's different. So, our population assumption, the null hypothesis, always is a statement of equality. We might say something like, when asked this question, the long run proportion of MCC students that pick right front tire is 1 out of 4. So, our population of interest are MCC students, and we think that they're just in general going to pick right front tire in 1 in 4. It's a 1 in 4 chance they pick it. Symbolically, that might look like H sub 0 says that P is equal to 1 out of 4, or in other words, 0.25. Now, the alternative is what the researcher wants to show. This means that when asked this question, the long run proportion of MCC students that pick right front tire is more than 1/4, or in other words, that P is greater than 0.25. After we've come up with our statement about the population, that's when we go and collect our evidence. So we see here that this professor collected evidence from a survey and found that 29 out of the 58 students said that they would pick right front tire. So that's a 50% result. 50% of the students that were surveyed picked right front tire. This is why he's thinking maybe you're going to pick right front tire more often, because he had a result where 50% of his class picked right front tire. So here we have our sample, and we want to analyze what's the probability of getting a sample of 50% picking right front tire. That's what we want to determine. Now, previously we've used the normal calculator, but this is where we're actually going to turn to StatCrunch and use a different method in order to do that. So in StatCrunch, we're going to go to Stat. The parameter we're using is a proportion, so I'm going to choose the proportion stats option. We're dealing with only one sample, and our information that's given to us is coming already summarized. So we're going to choose with summary. These are the steps we're going to use to perform a hypothesis test in StatCrunch. So we know from our information that the number of successes was 29. The number of observations were 58. And we wrote our null hypothesis to say that P would be equal to 0.25 because it was a 25% chance of picking right front tire. And the only other thing I really need to change is this inequality symbol. We want to show that it is greater than, that it is more often chosen. From here, we're going to hit compute. And you'll see a screen that looks like this. So let's take a moment and analyze this information here. The output screen shown from our StatCrunch window gave us the p-value that we're interested in. So the p-value here at the very last column of this screen says that it is a less than 1 in 10,000 chance of that occurring. So we can pretty much call it 0. So the p-value is the output portion I'm interested in from this screen. I do want to take a moment, however, and discuss what the other output values are, just so that you understand what we're also given here. First of all, we have our sample proportion. Now, our sample proportion was that 29 out of 58, right? That's our p hat that we've defined earlier. The standard error was previously defined for us as the standard deviation of our sample proportions. We calculated this by hand by taking p, 1 minus p divided by the square root of n, and used that in our normal calculator, but we're redefining it here as that standard error. And then finally, the z-stat. You need to be aware of z-stat in case you're asked a question like this on your homework, but we're going to say that z-stat is that z-score of our sample proportion. In other words, what's the z-score for p hat? We also have seen this, or will see this, as denoted as z sub naught. So your z-stat is also called z sub naught, and it is what we call the test statistic. This test statistic, if you were using a different method to analyze your hypothesis testing, it's a different method, but this is what you have. That's what z-stat tells you. This information here is going to be needed possibly when you answer questions in your homework. There's probably a question that's going to be referring to identifying the test statistic or Z naught. And so that's where it's at. Now let's turn back to why we ran the test. We ran the test to determine the probability, or the p-value, I should say. Remember, to interpret p-value, the p-value is really just the probability of getting our sample or more. So to interpret it, I can kind of refer back to what we started. Assuming that students pick right front tire 25% of the time, we would expect to observe those 29 out of 58 picking right front tire in less than 1 of every 10,000 repetitions of this study. And I put exclamation points on that because that just really is highly unlikely to happen. Now, our process that we've been practicing on for our steps for hypothesis tell us that we need to compare the p-value to the level of significance. And we're going to say that that p-value, which is in essence 0, is obviously less than 0.05, which is what we are assuming our level of significance to be. We were not told in the original problem what alpha was, so we assume alpha is going to be 0.05. So all that's left to do here, now that I've analyzed the data using StatCrunch or some sort of technology and interpreted the p-value, the only thing left to do is to make a conclusion. So how do I go about doing that? When we make our conclusion, you need to be very careful and understand that we never actually accept the null hypothesis, where rather we state our conclusion as in terms of the alternative. And let me just explain what I mean by that. If we look at this in terms of the court system, most of us are familiar with, because we've watched television or maybe even have been on a jury. But when you are a defendant, you are presumed innocent. That is the basis of our judicial system here in the United States, that you are presumed innocent. That's going to be our null hypothesis. However, when the jury comes out, if you think back, like I said, to any television show you may have ever watched, the jury never finds the defendant innocent. They will either say that the defendant is either guilty or not guilty. So, if innocence is what we consider the null hypothesis, guilty has to be the alternative. And think about that. The court system is stating that the defendant is either guilty or not guilty. In other words, they are putting the conclusion in terms of only the alternative. We're going to discuss this further in a different video, but that's what we want to understand, that we are never accepting just the null hypothesis. We are actually stating things in terms of the alternative. So how do I go about doing that? Here is a little sentence to help you with that conclusion. Your conclusion is going to start by either saying there is or is not, pick one, sufficient evidence to conclude that, and then here you're just going to insert your statement that you already wrote for the alternative. So there either is or is not sufficient evidence to conclude something about the alternative. Now let's go back and look at that flat tire example we were looking at. Remember, these were our two statements about the population. We've got the null and the alternative. And our conclusion is only based on the alternative. We found, since the p-value was less than alpha, that we are going to reject the null hypothesis. So how does that look? If we reject the null, we're actually in favor of the alternative. So if we are in favor of the alternative, we might say something like, there is sufficient evidence to suggest that the number of MCC students that pick right front tire is more than 1/4. And you can see that when I'm inserting, starting here where my mouse is hovering underneath the word number, is a similar statement as to what we already wrote previously when we took the time to write down in words what the alternative hypothesis looked like. So this is a good example of how we work through the process of hypothesis testing.